Tuesday's edition of Cracking the Cryptic, and yes, I have managed to get the day right today. Apologies to those of you I confused yesterday by alleging it was Sunday. That is because it was a bank holiday here yesterday, and that has totally discombobulated me. Now, you may be looking at this screen thinking, how on earth can this be a Sudoku? And with good reason. This is called the Dutch Miracle, and it's by none other than Ard van de Wetering from the Netherlands. Now, Ard is a mighty man in the world of Sudoku, an absolutely brilliant setter of puzzles, and in fact responsible for what I think I could allege fairly would be the most viewed Sudoku of all time, because we had a video a few years ago that has had 8.5 million views. 8.5 million people have watched Ard's Sudoku, which we christened a Sudoku with only 4 given digits. Well, Ard has trumped that here by halving that number to just a 1 and a 2 in the corner. Now, we've seen Miracle Sudokus before, but I have to say I've never seen one with anything like this rule set. It is absolutely fascinating. And I'll read these out in a minute. It's a version of Dutch Whispers, if you're familiar with that rule set. So that's what we're going to be doing today in attempting to solve this rather sparse grid. A couple of things to mention before we do that. I've got 2 birthdays to talk about today. So firstly, Kyle, or it might be Kyle, who turns 20 today. So congratulations on that, Kyle. Kyle from the north of England. And Kyle, I was especially gratified to read that you actually enjoy our ASMR Sudoku video that we released a few years ago. That definitely, that was Marmite for people. Some people loved it, some people absolutely detested it, but we did do one ASMR video, and there is at least one person I now know who likes it, so thank you for that. Now also, Kyra, from over in South Dakota, it's your birthday today, and your boyfriend Justin got in touch with us to say you'd appreciate a shout out. So I hope you've had a very splendid day too, with of course very much cake. That is always important on a birthday. So what else have I got to tell you about? Well, if you're a patron of the channel over on Patreon, check out the monthly reward. We have had over 1,000 correct entries so far, and you've still got loads and loads of days left. The reports suggest that this one is, well, it really is genuinely approachable, especially if you take on the normal version. We released 2 versions, a hard version and a normal version. The normal version is definitely doable, so do have a go. And if any of you do get stuck, go over to the Patreon chat over on Discord, and you'll find people who can help you. And other than that, I have made a Ricket. I said a couple of days ago that we were going to be live streaming Myst. Well, I downloaded Myst, and I checked that my computer could play it, which it could, but I immediately got motion sick. So Myst is not on the agenda anymore. Apparently the game we might look at now is called Goro Goa. I'm probably saying that wrong. It's not a word I'm familiar with, but that is now apparently completely motion sickness free, and that's the one we're going to have a go at. Maybe tomorrow night, even Wednesday night. Keep an eye on our Twitter and also on the community page on YouTube, and we will firm it up then. But if we do it tomorrow night, it will be at 10 o'clock UK time, and we would love to have your company. Now, what are the rules of the Dutch Miracle? What has Ard got for us? Let me read them to you. Normal Sudoku rules apply. Along each positive diagonal, i.e. from southwest to northeast, which is from here to here. So each of these diagonals, 2 things apply. Firstly, all the digits are different, so all those digits are different, and then all these digits would be different, all these digits would be different, etc. And secondly, adjacent digits, i.e. those touching at a corner, so these 2 for example, must have a difference of at least 4. So in this puzzle, therefore, this being a 1, this would have to be at least a 5. So it's a 5, a 6, a 7, an 8, or a 9. And then let's say it was a 9, the next digit would have to be 5 or lower, 5, 4, or 3. It couldn't be 1 or 2 because 1 and 2 are in the box. And that, believe it or not, is everything. That is the complete set of rules necessary to yield a unique solution from this puzzle. That's supposedly, at least, logically findable by a human being. Now, that is what I'm going to attempt to do now. Do have a go at the puzzle yourselves. The way to play is to click the link under the video. If you go down to the video description, you'll see a link. You can click that and play the puzzle on whichever device takes your fancy. But now I get to play. Let's get cracking. And I am tempted very much to actually highlight these diagonals. It will make me feel like I'm making progress if I do this. Because we know that on each positive diagonal we can construct in the puzzle. Let's keep going this way actually, and then we'll make a decision about what colours we do the other way. On each positive diagonal we can't repeat a digit, so that's probably going to be worth keeping track of, isn't it? I'm trying to keep the colours as well as crazy as possible, it seems. So now if we do that one again in yellow and then we sort of propagate outwards, we're going to have something very, very beautiful to look at, even if we can't do the Sudoku that results from it. So we need grey, and then what do I go to then? Green, blue and yellow. And now what do we do? So probably we start with the main diagonal, because at least we know that there's one of every digit on that diagonal. And Dutch whispers are awkward creatures, because German whispers, I know many of you will be familiar with German whispers, but in a German whispers puzzle, the difference between adjacent digits has to be 5, and that leads to an oscillation, by which I mean if you divide the digits up into the low digits 1, 2, 3 and 4, and the high digits 6, 7, 8 and 9, then you know that a German whisper line oscillates from, so if you have a low digit you then have to have a high digit, because you've got to be 5 different, and then you've got to be low again, and you can never put a 5 on a German whisper. Now with a Dutch whisper, unfortunately, you can put 5 in a cell, and that means you don't quite get oscillation. You get oscillation, i.e. if we imagine the digits 1 to 4 and the digits 6 to 9 as two parcels, you do get oscillation unless you hit a 5 along the line. And if you hit a 5, then the next digit has to be 1 and 9, and the polarity can switch. Yes, so that's right, isn't it? So if this went 5, 9, you can see that we have changed, if you like, the natural way that this line would oscillate. So normally it would go 1 and then a high digit and then a low digit and then a high digit and then a low digit. But when you have the 5 there, we actually change that. We get 1 medium high, and then this is not low then. So if you can see, if that's a 7, is that a good choice? Yeah, that works. If 1, 7, 3 would be absolutely legitimate, and then you continue up the line from there. But this is low. But where 5 makes an appearance, you have to switch to 9, and that's going to be the challenge. But there does have to be a 5 on this diagonal. Yeah, that's interesting. So does this have to be the 5? No, because 5 could go in the corner. Bobbins. Ah, that's annoying. That was almost a sensible thought. Obviously, if 5 does appear in the middle of this diagonal, because it has to be flanked by 2 digits that are at least 4 away from it, it would have to be flanked by 1 and 9, and that would break the diagonal if you try to put it here, because we'd have 2 1s on the diagonal. So the 5 could go here with a 9 here, but unfortunately the 5 could hide away in the corner with a 9 beneath it. And then the problem with 5 goes away. So that's really annoying, actually. Okay. So the next digits that we should probably think about on this line are 4s and 6s. 4s have to be connected with 8s and 9s, and 6s have to be connected with 1s and 2s. Oh, yeah, right. That's important. That is important. because of this 1 in the corner. Now, so where does 6 go on this diagonal? Well, the only place it could go and be next to a 1 is here. But then we'd have to put a 2 on the other side of it, which we can't do. So 6 is not here. Now, if 6 is anywhere else other than in the corner, it needs to be flanked by a 1 and a 2, and it couldn't be without repeating the 1. So 6 does live in the corner, and it must be next to a 2, because it can't be next to a 1. And now 5 is problematic, because we said 5 could go in the corner, which it now can't. So now 5 must go here and be next to 9, and we are actually getting somewhere. So we still need... So now we've used the 5, we can use the polarity switching to help us. So this has got to be a low digit now, i.e. a number lower than 5. Then it's going to bounce up to a higher digit. Then it's going to bounce back down to a lower digit, and then it's going to bounce back up to a higher digit. But that digit must be difficult. You can't connect 7 to 4. So yes, so this can't be 7, because it would have to have a 4 on one side of it, and that won't be 4 away. So this is 8, this is 7, this is 3, and this is 4, and we've done one of the diagonals. That's quite lovely. And therefore, well, now the problem's going to be that all other diagonals are far less clear, in the sense that even if we take one of the 8-cell diagonals, like this one, there's a digit missing from this diagonal. So the sort of the restrictions that would apply to digits like 4, 5, and 6 will only apply to 2 of those 3 digits, because one of them might just be missing altogether. Right, each box though has to have a 5 in it. So the central box has to have a 5 in it, and wherever that 5 goes, it must be flanked by 1 and 9 on the diagonal. So if this was a 5, you'd have to put 1 here and 9 here, because of this 9. If this was a 5, you'd have to put 1 here and 9 here. But that doesn't actually... Wow, that doesn't seem to do much, does it? So maybe we've got to use the fact that we now have 2 2s in the grid. It's the only digit we have 2 of. So the 2 in box 9 is in one of 4 positions. And the problem with 2 is it's not very restricted at all from a whisper's perspective. I mean, if the 2 was here, these 2 digits would have to be at least equal to 6, and that's not very constrained at all. Presumably the same is true up here. In fact, 2 could hide in the corner up here, and a 2 in the corner is not subject to any whispers restriction. So 2 is not where we have to, it's not what we have to think about. We've got to put 4 and 6 in this box, so that's probably worth thinking about. So 4 has to be next to 8 or 9 on its diagonal. So if 4 is in a yellow cell, it must accompany 8 within the box, because it can't accompany 9. But if 4 is here, this could be an 8 or a 9. And 6, right, okay. Where does 6 go? Where does 6 go in this box? Sorry, I didn't think about this, but like there's already a 1 and a 2 in the box. 6 can only go next to 1 and 2, so I think 6 has to go here, because otherwise anywhere else it needs a 1 or 2 on the diagonal with it. So this is 6. This is a 1 or a 2. And that is important. Why? That puts a 6 into a 2 by 2 up in box number 1. And that's almost interesting. because remember, wherever the 6 goes, it has to be flanked by 1s and 2s. So if this was 6, you'd have to put 2 here and 1 here. 6. No, okay. Don't know if we can disambiguate that, but we might be able to. Right, let's have a look at where 6 goes in box 4, because it can't go there, because that would need a 1 or a 2 here. So 6 is in one of these cells. And I want to say, is there some reason? There's probably a way we can. Yes, okay, but this is a 1 or a 2. So this can't be a 6 because that would have to be flanked by 1 and 2. So this is not a 6. This is not a 6. It's already on that diagonal. Good grief. So 6 is in one of these 2 cells now. So 6 in the central box. Is in one of 4 places, I think. No, that's wrong as well. Gosh, this puzzle's strange. Okay, this can't be a 6, because if that's a 6, you'd have to flank it with 1 and 2, and there's already a 2 on this diagonal. So 6 is in one of those 3 cells now. Now, let's just check all of these. That would lead to a 1-2 pair in those positions. Might be possible. 6 here, 1 and 2 in those positions. Yeah, we haven't got the 1s and 2s here aren't seeing these yellow diagonals, so I think all 3 of those might be possible. I'm not going to commit myself harder than that. They might be possible. Now, a 6 in here would cause a 1-2 pair here, and we would know the order. This would be 1, this would be 2. So maybe, actually, yes. Or maybe no. I can't get my head around this at all. If this is 6, you've got to go 2 here and 1 here, which would stop this being a 6. If this is a 6, though, you could go 1 or 2 here and 1 or 2 here. And then you're not putting any pressure on this digit, I don't think. This is tricky. This is really difficult. I'm not that surprised. A puzzle with only 2 digits and with a very, very short rule set is difficult. I shouldn't be shocked at all, should I? Oh, this has just died a death. So 6 over here is in one of 4 places. 6 in box 9 is in one of 4 places. No. 6 in box 9 is not in one of 4 places, because remember, if we put a 6 in row 8 here, what digits have to be on the diagonal in column 9, in row 9? We've got to put 1s and 2s in. So you can't put a 6 here. If you put a 6 here, this needs to be a 1 or a 2, and it can't be either. The same is true for that cell. So actually 6 is not in those positions. So 6 is now reduced to... Oh, I've got it. I've got another digit. Right. 6 in box 8 is restricted, because that logic we've just done for the 6s in this domino applies identically for the 6s in that domino. We'd have to put a 1 or a 2 in the bottom row, and we can't. So actually, this is the 6 in box 8, which now must be flanked by a 1 and a 2. So that's not a 6 now in box 5. And so now I'm wondering about these 2 6s. So if... Whoa, hang on a moment. If that's a 6... Oh no, it's okay, I think. I was just noticing, if that's a 6, I'm going to get a 1-2 pair in this row, which is going to prevent these 2 from being 6s by the 1-2 rule, but that 6 would automatically reduce the possibility of these 2 being 6s. Okay, let's have a think about this. So if this is a 6, this square here would be a 2, and this square here would be a 1. Now, is there anything wrong with that? Answers on a postcard, please. I can't see anything wrong with that. What about if that's a 6? If that's a 6, this has to be a 2, and this has to be a 1. Oh, so the 2 is always beneath the 6 on this diagonal, and the 1 is always above it. I'm sure that means... Oh no, does that mean this can't be a 6? Or am I confusing myself? I don't think that can be a 6. Because if that's a 6, where are we going to put the 1 on its diagonal? If that's a 6, I can't put a 1 here, and I can't put a 1 here. And I can't put a 1 here, because if this is a 6, this is a 6, and there's a 1 in this box already. So that is not a 6 anymore. Now, we might be able to repeat that trick. If this is a 6, surely it's the same logic. I've got to put a 1. Oh. No, hang on. Maybe it's... No, it is the same. If that's a 6, I can't put a 1 here. And this is a 6 in box 5, which puts a 1 here. So you can't put a 1 either side of it. So here we go. So now I've got... Now I know that there's a 6 in this domino, which means this is not a 6. This is a 6, which means this is a 1. This is a 2. And we are cooking with gas all of a sudden. Probably. He says, and then immediately comes to a complete and utter standstill. Oh, right, this isn't a 6 now, is it? This was never a 6 because it's on the red diagonal, and I've only just noticed that. Right, that's not a 6. So now I've got my 6 in box 6, and I've got my 6 in box 9, and I know these are flanked by 1s and 2s. So this cell, oh, that cell is a 1. It sees a 2 in column 8 already. But these two digits don't seem to be resolved. Oh, although I've got a 1-2 pair in the bottom, in row 6 now. Oh, so I can place, right, I can place 2 in box 5. 2 can't go there by Sudoku, it can't go here by Sudoku, so 2 goes there. Now that's probably got some profound implications for some middly digit along this yellow diagonal. But also, oh no, hang on, it's got other easier implications. Look, that's a 1 and a 2. This is a 1. Why have I got a 1 in this cell? Is that in some way relevant? Yeah. Okay, let's ask where 6 goes in this little 2x2 now. It can't go in either of these two cells because it will need to have a 1 or a 2 lower than it on the diagonal, and there's now a 1 and a 2 in row 4. So those are not 6s. If this or this is a 6, you have to have a 2 beneath it. So there is definitely a 2 in one of those cells. There's definitely a 1 in one of these two cells. And that means this cell would have to have a 2 here and a 1 here. Bobbins, I'm sure this is somehow resolvable. I just can't quite work out how to do it. Alright, let's go back to having a look at box 5. We still need 5s, 7s and 9s. What can we say about that? 5 is going to be very important. Yeah, 5 can't go here, because that's going to require to be flanked by 1 and 9. Oh, 5 could go there if that's a 9. Look, that one might work. What about this one? Oh, this is beautiful. Right, that's not a 9. Sorry, not a 5. Because if that's a 5, what do you... Well, A, it's next to 2, which is... That's not... That's so depressing. That's not what I was looking at. I was looking at this cell and seeing it can't be a 1 or a 9, so that was how I proved this couldn't be a 5, but there is a simpler way. It can't be next to 2 on the diagonal. So that means that 5 in this box goes here. We need this digit to be 4 away from 5 and not to repeat the 1. So that's a 9, that's a 9, that's a 7. By Sudoku, this is a 9 now in box 4. Good grief. Okay. Now, does this keep going? Please keep going. What should we say now? There's a 6 in one of these two. So and this can't be a 6 because it would need a 1 on its diagonal. So we can get the 6 here. Oh, it can't be a 6 because there's a domino here. There's all sorts of Sudoku possibilities that will help you if you obey them in the puzzle. That's now a 1. These are no longer 2s. So 2 lives over there. Oh, 2 can't be here because these have to be different by 4 at least. So this is a 2. No, okay. This digit maybe this row. We need 3s, 7s and 8s. Now, that cannot obviously be 7 or 8. No, this needs to be low, in fact, so that's got to be 3, leading to a 7-8 pair over there, which doesn't seem to be resolved. Let's keep going down this diagonal. This square has to be 7, 8 or 9, and it can't be 7, it would repeat. It can't be 9 by Sudoku, so that is 8. 8 must be 4 different from a digit here. Yeah, okay, so it can't be 3, 2 or 1, so it has to be 4. So these two squares are 3 and 7, and there's a 3 here, so that's all fixed. This is actually starting to get easier, I think. I mean, it's not that surprising we're getting digits in, but it's almost becoming... Yeah, oh no. Yeah, what's that digit? That digit's got to be 4 away from 9, but not 5, and not 1, 2 or 3. It sees all of them, so that is 4, which means these two squares are 3 and 5, and that's 3, and that's 5, and that's 5 on the diagonal, which requires a 9. This square's got to be 4 away from 9, and therefore it is 5, or no, it's not 5, it's not 1, 2 or 3, that's 4 as well. These diagonals are all similar, aren't they? 6, 1, 5. Yeah, there's cycling. There's some sort of cycling going on. Don't quite. Yeah, 8, 8, 3, 7, 2, 8, 3, 7, 2, 3, 7, 2. So, oh, because there's an 8 missing from this diagonal, which is why it's not 8, 3, 7, 2. So there's some sort of cycling. 2, 6, 1, 2, 6, 1, 2, 6, 1. Yeah, there's a pattern emerging. I won't use the pattern because I don't understand it to actually fill the puzzle in, but it might be a quick way of doing it if you want to, if you're minded to use that sort of thing. This square's not a 4, so this is the only position for 4 in this column. 4 must be 4 away from a digit, so that's 8, that's 7. 4 has to be 4 away from this digit, so it must be 9 because it can't be 8. This has to be 3, 4 or 5. It's not 3, it's got to be 4 or 5. It can't be 4, that's already appeared on the diagonal, so that's 5. This is 3 or 8 and it's not 8, so that's 3 by Sudoku, that's 8. 8 needs to be next to lowish digits, doesn't it? So this has got to be 3 because it can't be 1, 2 or 4, and this square here therefore has to be 1, 2, 3 or 4, and it can only be 4 of those. 4, 8, 3, 4, 8, 3. So again, confirming our opinion about cycling. This is 7, this is 8. These two squares are 7 and 9, which is resolved. This square here is a something, 5. 6, 1, 5. 6, 1, 5. Yeah, all looking good. That's an 8 by Sudoku. That's a 3 by Sudoku. That's a 5 by Sudoku. Okay, let's see if we can finish this off with some sort of aplomb. We need 2s, 4s and 5s along here. So 2, 4, 5. That's not 2. That's not 5. and that's not 4. But this has to be 4 away from 1, so it has to be at least 5. So 5, 2, 4 get filled in. Now these squares have got to be 6, 7 and 8. And therefore that's got to be 8. It's the only digit that's 4 away from 4. And this is 6, 7, and there's a 6 here. So then Sudoku takes over. This column needs something. What is it? 2 and 8? Yeah, I think it's 2 and 8, so we can fill those in. This column, oh no, let's look at that column. 1, 3, 5. Yeah, 1 there. So that means that this 6, oh yeah, we need to always flank a 6 with 1s and 2s. I think there's going to be loads of ways we could go about doing this now, because once you get a few digits in this, it is clearly very, very tractable. We need 4, 7 and 9 there. So that's a 4, which is working. This is 7 and 9. Yes, and the 5 helps us. That can't be 7. So that's got to be 9. That's got to be 7. And then we go 4, 7 and 8 here. So that's 4. That's 7. That's 8 by Sudoku. We go 3, 6, 9 here. That's got to be 6. 9, 3. And we go 2, 5 into those cells. 5, 2. 5, 9, 4. Let's just check that that looks like it's cycling. 7, 2, 6, 1. 7, 2, 6, 1. I've seen that before. 6, 1, 5, 9. 6, 1, 5, 9. I think that's the solution. Yay. That's just stunning, isn't it? It's just stunning. It's yet another ridiculous puzzle from Ard van der Wetering. I don't know how you come up with ideas like this. Oh, you can put a 1 and a 2 in a corner box of a Sudoku, have some Dutch Whispers rules and a no repeat rule on the diagonal, and the whole thing will resolve. But the clever thing is not just to have all of those thoughts, which are clever enough. The clever thing is to realise that if you do have those rules, the solve is actually very findable. You know, it's very logical. You know, all we did was sort of understand the constraint around which digits were going to be the most restricted, and then think about those digits in relation to what we had. And eventually we alighted on the fact that 6s were very restricted in, I think it was this box, and this box it was really restricted in. And that gave me the 6 here. And then all of a sudden you're away and you can create these beautiful strings up all of the diagonals. I hope you enjoyed it. I hope you had a go. Let me know in the comments. I do enjoy reading them, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.